Okay. I'm trying something new today. And that something new is, that might be interesting to share a view behind the scenes of what it's like making content for a class. Now, I have a YouTube channel where I've put up a bunch of intro CS materials that I've made. You know, backing up even a little bit more, I don't expect anyone will be watching this, but if they do, you've come across my channel. My channel has some stuff about me, and I really like to teach, and I've taught a few classes. In particular, I spent a semester lecturing at Howard University in DC. So I taught a course that looked like this. CSCI 100. And the goal of this course was covering kind of all of the intro material in computer science. So how do you introduce introductory material to new students in computer science? So I spent a lot of time figuring this out for myself. And made a lot of content. I'll pull up some of these slides, slides and lecture videos if I go over here on this YouTube channel for the course, which is CSCA 100. It's kind of fun to see, actually. Some of these did surprisingly well now.
Hello, everybody.
Whoops.
Well,
So like, I have an extension here that blocks showing details of the videos, but I think the most popular video had like 4,000 views, but it's because it explains what images are. Which is kind of funny in my opinion. But just a moment as I figure something out here. Okay. Yeah, so this summer I am teaching at Jam Coders. Jam Coders is this really intense summer coding program that's supposed to basically go through really the entirety of Intro CS and computational thinking in 4 weeks. So the idea is you get together 100 really smart kids, they're all in like 10th, 11th grade in Jamaica, and they're going to kind of speed run intro computer science. Again, with the goal of getting really good at thinking computationally, getting ready to take classes. So my thought, well, because I had taught at Howard before, Jelani, the organizer of the program, asked if I'd be willing to come lecture for one of the weeks here. And I said I'd be willing to. And so there's this great team of 4 lecturers, each teaching a week, and a bunch of awesome teaching assistants. But this is coming up in like a week. And I wanted to spend some time preparing my materials. And I've been doing this on my own, but I thought, why not try to record something and show what happens behind the scenes in making these materials. Usually I would try to make a video that's kind of more condensed, but I don't have the time to go edit. So I thought I would just record what I'm doing and how I think through what should go into my materials. So with that in mind, I'm basically just going to be working and thinking out loud as I go, just to show what's on my mind. So the structure of the course, actually, I was just preparing this first lecture that's supposed to introduce the structure of the course. So I'll jump down. Structure of the course will look like this. I'm there lecturing for 5 days. Each day there's an hour-long lecture and then 2 hours of lab in the morning, and the same thing in the afternoon. And so basically each day I have 2 hours, 2 separate hours. So I have an hour to show the students something, get them thinking about it, maybe in a slightly interactive way, and then they have 2 hours to go apply it. So I need to make sure that whatever I'm lecturing is aligned with what's planned for the labs. It's kind of a little circular. They'll adjust the labs based on what I'm lecturing too. But this is actually a really hard week to teach. Like, I'm taking the first week. The goal of the first week is actually pretty tricky. So I've already done this, and I spent a little bit of time thinking, but for any course, it's really important to have kind of a goal in mind, like a guiding mission or a guiding principle. And this was mine, which is to build a core foundation of computational thinking through studying data structures and algorithms. And Jelani is going to be teaching them algorithms, or we'll be teaching them data structures. Timnit is going to cover, I write advanced programming. She's going to teach them about recursion, which, again, you take an intro CS class. Week 2, going all in on recursion is pretty intense, but also most classes don't meet every single day for 8 hours the way this one does. Or I guess 6 hours. That's why it's moving so fast. So I have this first week, and it's actually kind of challenging. Because I'm going to be taking kids that have literally never coded before, that are like probably really good at math, they're really smart, and I need to get them comfortable enough with Python to, in week 2, move on to doing recursion. So kind of the goal is to teach them enough programming stuff to let the programming concepts get out of the way and let them express the mathematical things they actually want to express. To be first recursion, and then other algorithms, and then data structures. Yeah. So let me also just check here briefly that this is actually working. Okay, this is my first time doing express the mathematical things they actually want to express. Okay, it's kind of working. Cool. Okay, so at this point, I can pull up my notes here. So I've spent a little bit thinking about curriculum already. And in fact, I'll pull up something else here. Just making sure it doesn't pop up where I don't want it to pop up. Okay. Yeah, so I was playing around with one of the TAs, and I wrote down my kind of rough plan. All right, so we can go back to here. Okay. The rough plan looks like this. Now, honestly, I'm still going back and forth a little bit on this setup. So clearly, day 1 needs to be variables, types, printing expressions, conditionals, operators, that sort of thing, the kind of really core building blocks. And looking at where we need to get to, by week 2, week 2 seems to be a bit of like tying in stuff from the previous week, and then recursion. A lot of recursion, actually. And, if I were teaching week 2, actually for a very similar program called ADIScoder, I did teach week 2. This was a couple years back. 2023, and the start of the week I went through review, and then I started doing stuff with images. Then we did recursion, and then they had a final project. Yeah, okay, kind of similar, actually. So my goal for this first week is going to be cover probably these same kinds of things, but I might rearrange them a little bit. So one thing that's kind of tricky to decide is what order to take these loops versus functions lists in. I'm very much leaning towards doing my loops first. I think I've seen this with students. They struggle to grasp kind of what the computer is doing and how and why. Loops are kind of one of the earliest concepts where they just it's just hard. I think it's especially hard if you're in CS, you're like an engineer or something, and you're used to thinking like a computer, like I am. It's hard to even remember when loops didn't make sense. But if you're coming from a world where you've never coded, loops make sense from the perspective of, let me just repeat things, but like, when do you use a while loop versus a for loop? What are they good for? Why would you ever do while true? That's kind of weird. So yeah, I think for now I'm going to focus on this first day. And particularly important to me is, I both have to make my lecture slides here, but I also need to make a collab, a Google Colab to go with this, for which I'm actually going to pull this up here. Take a look at how this is. Yeah. I probably am going to, let's see, we'll download this. Oops. Let me see if I can get this open in a collab. I do really quite like these collabs. Google Drive, and I should really put this in the right folder in my drive. Maybe I should do this the other way. Like, does Google let me do this? This would be pretty cool. Oh my gosh, it does. That's great. Okay, so maybe in these lectures, I'll do like, yeah, something like this. Whoops. Okay. And 1A will go in here, which is great. And then here I'm going to make my new collab. So it's always good to build off of what other people have done. Especially with teaching, there's so much stuff that people have done that it's almost silly to start completely on your own. So I'm probably going to come back here. Let's see, and I think I can do this. If I come in here, will this work? Yeah, cool. Okay. When I go to teach, I'm probably going to alternate between these slides and the notebook. So the setup is there's 100 people in a room, 100 students, and I'm going to be showing them. They're going to have, an hour with me, no laptops for them. They're going to have pen and paper, and then they're going to have 2 hours at a computer. And there is no way to keep them engaged with just slides, I think, in a way that's kind of memorable. So instead, I'm going to start with some context about what CS is in slides, and then I'm going to go back and forth and do demos as I go along. Now, I'm grabbing stuff from this, from Daniel here, who taught the first week of Ediscoder, only because I think the instructor who taught this first week of Jamcoder is these collabs. I assume he did more stuff during, because there's a lot of, some of these are a little sparse, and so I think they may not actually be as full as we intended. Though maybe some of them are actually. Now I'm taking a closer look. Yeah. Okay. So okay, starting off really intro CS, like there's a lot of things to build off of. So literally day one, the goal is going to be, see day 1A here. I have to break into 1A and 1B. So clearly kind of an intro comes first. But if I go and think about, what was it that I taught very early on in my intro CS class? I started off with some context on computers, if I remember correctly. I was like, okay, these are what bits are. Remember, the students actually really liked that for some reason. I tried also giving them a sense of what happens when you run code. It's not clear how useful that was for them, actually. But there was some context on like what are languages. And I kind of like that. So I probably will start off with some content. I have my intro slides where I talk about why I study computer science, and what this course is, what the point is, the structure of the course. Let's see. Probably I do want to have a sense of the objectives for the week. Probably some cute thing like that. Python. Learn to write very simple logic. Yeah, so I think I want to get at, I kind of want to get at that the goal isn't just to write simple logic, it's to, it's like learn to capture, I don't know, logic in text, maybe? I mean, I'll come back to that. Learn to code, yeah, learn to capture, express logic. Maybe that'll make more sense for them later. So learning to code, speak computer, learning to express logic, that's interesting. Then, what's the other thing? What else do I want them to do? Okay. Units of work. So work. I'll kind of come back and look through this more later. But okay, I definitely want to start with, I have an hour. I want to talk about like what programming even is. I think if I remember Kingston, oops, yeah, to Kingston, Jamaica, whoops. All right, yeah, so the University of the West Indies. So this is where the class will be. I like to generally use examples from class. I think they're kind of cool. I probably will say something here about how text, the relationships in code and text. Text is kind of like what humans use, code is what computers use. And then there's languages for both. Many programming languages. Okay. So I'll point out that there's like honestly, I might keep some of these slides. I think I will go back to this lecture 1 and keep some of the slides. It feels like this kind of context is pretty useful. So like, and we'll see, I might come back and cut some of this. But I kind of want to tell a little bit of a story here. And code. Right, so the story I kind of want to tell is you write codes to accomplish tasks. And the thing is, you're going to write code that you run. The way that code gets run is passed through a compiler, which produces something in machine language that the machine understands. There's a bunch of different languages that all get translated to like a way of controlling the machine. I might tell them something about kind of robots and things here. Okay. Actually, yeah, this is probably a good amount of context on like what is programming. I'm not sure how much it makes sense to start with these like computational tasks, honestly. Because I had this here because I was looking at the previous instructor who on day 1, yeah, Boaz, whom I've never met actually, though I'd love to meet. Starts off with this idea of like a computational task, and you have these inputs and outputs, which I think is nice and all. It's good to be mathy, but I think this can be kind of overwhelming, this like formal definition of an element in an algorithm. Yeah, my intuition just tells me I think they won't be ready for this on day 1. Like, I think I'd rather start with something a little bit more directly coding oriented. So it looks like Boaz in the first lecture, I think what he's going for here is, I think he wanted to show like, look what programs can do. Isn't this cool? Which is maybe pretty cool, but I feel like for that, I might go back here for Adi's coder. Whoops. Need to figure out where my code base is. There's a pretty cool demo from Adi's coder of the project they built at the end of the second week. Cool, yeah. And week 2. Answer is week 2. Exercises? I wonder if it's here. That's kind of interesting. Filter problem. Yeah, I'll have to go back and find this. I mean, I have an example up on the CSA 100 website. You can like write some code that will go and show images and apply algorithms to them. Right, this will make me really blue, which is kind of cool. And there's all these more complex filters, like there's this blur. Someone did blur. Oh yeah, I had one student who did this sketch filter. So I kind of want to show this to them, where you can apply filters to images and do all sorts of cool things. Yeah. So honestly, I'm probably going to mix what the last 2 professors have done. The goal for this first lecture will be intro, get students excited, and cover basics. Now, I'm not even sure that I'll get to... I should get to conditionals. Okay. I probably will do it like expressions and operators. probably something like this, honestly. Yeah. Yeah, this makes a lot of sense to me. Okay. So I kind of want to show a demo of what you can do. Yeah. So yeah, okay. I know what I'm going to do. I will, after all, go back to my week 2. Oh, yeah. I just remember there's a set of cool demos that I could do. It was 20, 25. Yeah, I'm just trying to think what order I want to do this in. So by the middle of next week, probably will ask them if they're like on Instagram. Actually, I don't know how big Instagram is in Jamaica, in Kingston. It'll be like Snapchat. So how does this work? I think there's some way to like embed code snippets, find and replace. Yeah, Jupyter Notebook, bed library, maybe. I just really want to show this to them. See, this won't work right now at all because there is no simple image. But there's got to be some way. Okay, I'm going to do it this way. There we go. Code. I don't want them to see this. That's the thing. Okay. Yeah, there we go. Oh my gosh, it's actually pretty cool that works out of the box now that I think about it. Okay, so this simple image thing is just, I mean, like literally, I adapted this CS 106A at Stanford, which I taught a version of 2 summers during COVID, has a image that makes, this class that makes making images easier. And I adapted it for Adidas Coder. I just really liked it. Okay. So I think what I'm going to do is load up. There's some way to load existing images. Yeah. Where is all of this? All right, week 2. Okay. Right, is it like 7A or 7B or what? Oh yeah, I like this guy. I'm probably gonna make this super interactive. Like I'm gonna ask them what their favorite color is. Okay, so this one's kind of fun. I want to do something with an image though. That's important to me. Yeah, of course there's no image. How do I embed? Oh, cool. Files icon. Yeah, there we go. All right, this is what I wanted. So let me pick something. Kingston, Jamaica, famous locations. I'm doing this because the last time when my last few times teaching, it really helps to pick something that's famous. Devon House. I wonder what's super famous here. National Gallery of Jamaica. Yeah, we'll see. Okay, so I'll probably just start with this. Maybe this will be the image I work with. Whoops. So let's save this image. Whoops. Devon House. I'll name it this. Whoops. Oh, cool. Yeah. So mysteryimage.jpg. Let's come back up here and I will upload mysteryimage.jpg. JPEG. It would be nice to read this image from does my library allow me to do that? Shoot. All right. Take a look. So how does my library? You know what? I should just do this at the end of my setup. I don't remember how to do this. Let me go ask for some help. but I can run in a Jupyter of notebook cell that downloads and saves the image from to a file locally called mystery image 1.jpg. Subsequent cell execution. Okay, so something like that. Let's try it. Whoops. Okay, cool. So I probably will actually just put that in here. Yeah. Yeah, exactly. Just don't want to give it away here. Okay. You save image of this, comma, to image 1. Yeah, so how about that? Just pick another. Cool. I feel like that's beautiful. I really want to know the address for that. Okay. I'm spending so much time on this because it's pretty important to get the students like hooked or interested early on. Like they should see and be like, this is what we're building towards, what we're going to be able to do. Because I think without having that thing that you like can go do, it's hard to know why you're doing what you're doing. So I think as I'm showing this to them, I will tell them not to at all worry about what they're seeing. Mystery image 1.jpg. Ah, misery. Mystery. Oh my. M-Y-S-T-E-R. Let's see what's going on here. Slash content. Okay, they're all here. Maybe I'm just typing something wrong. I probably am. No, I'm not. Oh my gosh. Wrong error. Okay, great. Great. How did I end up downloading the Bob Marley house? I did not intend to do that. This was supposed to be... Whoops. See, I wanted this. I like that. Yeah, okay, I just grabbed the wrong thing. Okay, so let's come back here. Okay, cool. And I'm gonna label these. This is Devon House. Mystery image 2.jpg. It's going to be the blue hole. I'm gonna pick another mystery image. Mystery image 3.jpg is popular in Jamaica. If just I'm curious. Okay. Famous Jamaican football players. I think I'm still gonna go. Probably gonna try to get an image of Ronaldo. Copy image address. Yeah. Okay. Whoops. Whoa. Okay, so I wonder if this works. What if I remove the auth? Wow. Okay. So I really want a shot like that because I think that'll be pretty exciting to the kids. Okay. So actually that's all I have to do. Okay, I kind of like this. Let's take this image. It's not that big either. Ooh, really grainy. Whoops. Okay. So let's try that. All right, download all 3 images. Cool. Mystery image 1. Oh, I'm pretty excited about this. Okay, I feel like they're gonna really like this. Mystery image 2.show. Whoa. That just image is huge, right? I'm trying to remember if there's a way to resize. Oops. Okay, so I think mystery image 3 is going to be the right size. Yeah, mystery image 3 is good. I need a different mystery image 2, I think. Blue hole Jamaica. Okay, at this point, again, I'm not sure who would be watching this. I'm mostly saying this for myself. It might seem like a ton of time is being spent on this, and I am spending a lot of time on this. But I think it'll really pay off because I probably will keep going back to my running example. Yeah, like I think I'll go back to this as a running example as we go. I think I just want to like really highlight this comparison. I think Boaz here was going for something very similar with like the idea of show the kids what you can do. But there's a lot going on here. There's a lot going on here. Yeah, see, I can see what he's doing. Like he wants to show control flows, loops, variables, functions. These are all things you're going to learn. But I think this doesn't get the students excited because they don't know what any of these things are. Like they'll just be like, okay, that's a whole bunch of words. The students that are nervous are just going to be scared. And the students that aren't nervous don't really know what this is. So I think it might feel more approachable to start with images. But that's just my intuition. So we can see in a second. Okay. Okay, the fact that this is a review photo makes me think it might not be as easy. Okay, let's see. Yeah, see, this image is huge. Let's just see if this works. So I'm intentionally choosing like a couple of things that are like maybe the students will know right away. Please don't be massive again. All right. There's probably some way to resize these, but I don't know. Yeah, no, see, that's a CDN link, so I'm a little worried about it. You know, that's gonna be massive. Come on, what about just a regular size image? Where do I get that? Oh, this is so cool. It's so pretty. Very, very, very excited to go. Okay, finally. As long as this... Okay, so if I get this not from Google, but from this site directly. Okay, strange. Okay, what if I do this? All right, I'm gonna inspect this. I'm gonna actually dig into the code here and figure out what the heck is going on. Okay, so I have an image here. The viewer. Let's see where is the actual image? All right, it's hosted on Wix. I don't think that'll work. It's too bad. Okay, come on. This, no, still not it. Okay, what do I do? Tour. So this is the really big one. I'm looking for... Okay. This might actually finally be the one. Yes, there we go. All right, let's try this one. Oh, funny, these are actually all WordPress, right? It says like WP content. So let's hope they don't change anything. Okay. Oh? Can't identify an image? Really? All right. I mean, maybe it's not because it wasn't a... It is a JPEG file. Wow, this is the most challenging image to find. But at this point, I'm pretty committed. I'm decided for myself, I will go find this. You know, my alternative is actually to download a resized image, which I will very shortly switch to if this doesn't work. Okay, come on. Ah, all right. I might just have to come back to this. I'll find a different image for mystery image too. One, two, three. Okay. So we're actually just going to comment this out for now. Yeah. Okay. And the main thing I think I'm going to want to show them is like maybe something about how to it's like a filter that I really want to apply. I bet I have this locally on my computer. Let's see. Let's see if I can find it. Oops. Google Drive. All right. I don't have it locally on my computer. Okay. Well, I will quickly rewrite it. What I'm trying to do is make the filter, make a filter over top of the image. Or make kind of a nice gradient. It's just silly because I have the answers somewhere, but honestly, it might just be quicker to write it myself at this point. Okay, so we'll start with a blank image. And then for each column, this is random colors. I think I will do something where one of my favorite things to do is gradients. I like this. So I'm going to start with a 100. Yeah, let's do 300 by 300. A row. 255 by 255 actually. So I'll do 255 column. Look at that, that's kind of pretty. Row. Ooh. Okay, I'm gonna try a really fun one. So it's 255, G equals, yeah, there we go. G, B. Uh-oh. Okay. Yeah, all right, there we go. Okay. Some other cool ones. 17. All mod 255. Whoa. Oh my gosh. You know, I'm having fun. Yeah, I think I'll probably do this. I'll probably start with this. What if I make it a random number? Okay. Ooh, I don't think I like that. Yeah, I'll do this. Like there's so many things. I probably will go at this as like there's so many things you can do. I want to show them concretely what they will be able to do. So I kind of already like where this is headed. I am going to... Okay, the setup code needs to not be here. Okay, so the setup code is here. Okay, you know what? I'm doing this wrong. Wikipedia must have... It doesn't. All right. How is this so hard to get? Okay, maybe I'll do it this way. All right. Surely this will work. All right. You know what? That actually worked. All right, there we go. That's it. So okay, so I'm not going to show each of these images. I think I'm going to start with this. My random colors will go here. Okay. I like this. Colors. Okay, and the last thing I want to do is I think I want to overlay. Yeah. All together. So yeah, filter. Apply, gradient, filter, image. Oh yeah. I'm going to start with that. Yes, for each pixel. Set GB. Okay, so of course this is all black. Now, I need to remember how I do my... I think I have to do... All right, this will be just the original image. Okay. This pretty. Oh my gosh, that's a really cool one. Oh, wow. I like that a lot. I love this. Okay. Well, this is exactly what I wanted. So I have probably 10 minutes of stuff here where the goal will not be to like prove anything to them that they shouldn't be able to do it, that they need to be able to, sorry. Let me try this again. The goal of this is not at all to be like, you need to follow along with what I'm doing. The goal will be just watch, this is what you'll be able to do. If you like follow along each day. Oh my gosh, I actually really like this one. That's pretty. Okay. Okay. Cool. I love this. I love this. By the way, again, in the spirit of thinking out loud, since this is all going to video, The reason that this is such a good demo is because there are different kinds of learners and different kinds of thinkers. There are some people that are very visual, very driven by art, or the thing they produce is tangible. And this is the kind of thing that gets those people excited. Yeah, this, for example. All right, close column. You know, they will see the potential for kind of art in this. It's very visual. And then there are people that are also very kind of mathy and algorithmic, and they will want to know how the heck this happened. Like, there's clearly some sort of interesting pattern going on here, but why and how? So image filters naturally get both of those types of people excited. Yeah. Whoops. Okay. Let me actually turn on do not disturb here. That doesn't happen again. Okay. Now there's this question of what we should do next. This is probably going to be the first 15 minutes of class. I don't expect to have to spend so much time going forward, but having a sense of how I'm going to motivate people is actually pretty valuable. So okay, so backing up for a second, the thing, yeah, what is coding? Yeah. And I suspect even as I look at this, like, I think I'm going to spend less time in slides than I think I will. I'll probably spend more time in the Jupyter Notebook just like doing things with them. You know, that's my plan anyway. Oops. Yeah, there we go. So yeah, I think I will tell them this. Yeah, it's confusing. Close the notebook. Collab. Okay, so we're gonna jump over there. Yeah, I like this a lot. I think I really like what he has here. So let's see what it is that they will get to. Okay, because for jam coders, actually, they have, let's come over here, about syllabus. Yeah, okay, so the morning exercises are what's in this notebook. This is what they have planned. Comments, math reading. Yeah, okay, so this is a lot. We put a lot, but that's probably okay. Let's see what they had planned for the afternoon. Wow. All right, lots of stuff. Okay. My goal in this session is to just finish everything I'm going to do the first day. And I'm actually feeling pretty good. Pretty good about what I have now. I have way more slides than I need. Yeah, I have way more slides than I need. Yeah, because these as we have them now. Okay, let me also just make sure. Save. Locate and drive. This better be. Ah, okay. So this is going to move. Organize. Yeah. Move to my jam coders. Jam coders lectures, lecture 1. Okay, cool. Yeah, okay. I'm actually gonna go get more tea before I keep working. Okay. So we're going to go back to this. Now it feels like I'm far off, but I actually think this will now come together very quickly. If I take a look at, so ignoring these slides for a second, I don't think this is how I want to start. So I might, yeah, okay. What you can do with course logistics. Now, let me also just make sure, just curious. I'll restart this in a little bit. Oh, whoops. Okay. I didn't see. Slides and lecture. Okay, cool. Okay. A little bit of thinking here. Fun point, what you can do with CS. Okay, then my main goals are going to be, I want them to be prepared for this discussion. And this discussion, whoops, just jumping along here. Okay, or I guess we call this a lab. As these 5 things. Yeah, so we'll have basic building blocks of code. I think this order is kind of wrong. I probably will start with math, variables, okay. An expression. I probably need to mention the word expression. I will do that. We'll see if this is the right distribution of time. Okay, this is actually more or less correct. Instead we're gonna come over here. I think this is all overkill. Like, what is a variable? Yeah, I probably will skip a lot of that. I think I could just show it in here. So I'm gonna skip that example. Where's my lecture 1A? No. Probably figure out how to take attribution here later. Okay, so I like this start. Okay, you'll know. Again, I should just come back here. Ah, yeah, this is too much. This is way too much. You might ask me, what is a program? I probably need to say something about. Okay. Yeah. Like, math works the way you expect it here. Yeah, I like all of this. Okay. So actually, yeah, this is going to go further down. Yeah. So I think I'm going to choose operator here. Numbers and the operator together are called an expression. Running the expression is called maybe I'll do this in bold. We evaluate. Oops. Control M Z. Okay, there we go. We evaluate expressions to get their value. Okay. Okay. So I try to minimize the amount of like new vocabulary that I introduce when I'm teaching, but some of these words they're gonna just see keep coming up over and over later, and it helps to have a precise term for the words. Operator. For example, plus expression. Okay. Yeah. See, this is pretty important. This is actually pretty important. So you have to discuss errors early on with the students. Because if they don't know how to deal with errors, you've got problems. I'll put it that way. Because often they'll throw up their hands when they see them. So I will try to introduce errors. And maybe we'll solve them together. Okay. Yeah, this is going to be too long already. Okay. Definitely not doing lists here. We'll go over here. Go down here. Variables. Cool. We get just basically like a few minutes on each of these things. It's really not ideal. Yeah, this is tricky. Yeah, I kind of want them to actually... Variable. I'm gonna need to meditate on this a little bit. Yeah, it's hard. This is a little bit too much for the first lecture because it's going to take them a little bit of time to settle in, get comfortable. I want to get them excited about what they can do with CS. I probably will have, honestly, half an hour to teach. And in half an hour, it's tough to cover types. Yeah, but I could probably do it. Maybe the idea is just to kind of overexpose them the first day, show them a lot. In the very first lecture. Because the math will be fine. Integers. Okay, so types. Yeah, we're gonna do that. Variables let you store. You know, now I think about it, it shouldn't take actually that long. Variables. Just like math, so you can use variables in other expressions. equals so different, right? But in Python has distinct kind of things called types. Just types here. Okay. I actually feel not too bad about where this is at. I think I'm going to speed up this earlier part, or at least I'll go through it pretty quickly. Okay. Integers. So we can print x. Okay. Let's see. Float. Okay. I think I'm gonna print x. Probably will leave the Boolean operators for later. Yeah, I don't think I'm gonna cover them here because I think it's a little too much. And hopefully you don't need them. Oh my gosh, okay. They do them. Okay. it'll probably actually end up looking like this. You know, overall, I'm pretty happy with this. Oops. Yeah, so overall, I'm pretty happy with this. What this is going to do is it's going to get them excited about the material. It'll show them the basic building blocks, and yeah, I will probably shorten the earlier bits. The earlier bits of this lecture. But overall, the goal is just to introduce them to these ideas and then let them go in lab use the ideas. That's the goal. And I think what I have here will give them enough to do yeah. Okay. Yeah, I like this. Yeah. Yeah, definitely not going to do input here. I'm not sure why I have these slides. I'll put this in the extra slides. Okay. So that's most of lecture 1 done. I mean, I now have a pretty good idea of how this is going to go. Pretty excited. I'm going to show them these demos, get them excited. Yeah. I'm probably going to stop here for tonight. The main takeaway from what we did today is we thought a little bit about how the curriculum is going to look. Now, I do expect the later days to go more quickly because I have kind of some nice material already written up on, if we go back here, yeah, like for loops, I've got some material to explain what loops are and how we use them. Yeah. So, and I think I'll be able to reuse the Jupyter notebooks that exist, and if not, it'll be pretty quick to come up with some. I think, again, what we've accomplished today is we've put together the materials for day 1, the very first lecture, which honestly is the hardest because it's hard to give them enough to be able to go do the first lab, all within the span of an hour. So I think the second half of day 1 will be easier and the rest of the days will be not horrible. This has taken about 2 hours of work, and I've thought about this before. I think the other lectures, each one will take probably about half an hour to prepare, maybe 45 minutes. But with that, I'm actually going to stop and wrap up for the night. And this is what Pedagogy